Hello, Algebra. Hopefully your quiz went well this morning and it wasn't too stressful on you. Happy Friday. If you would please get out your note sheet if you have not already. We're going to be starting at 1-4, which is over relations today. So 1-4 relations, what it starts off talking about is the coordinate system. And so when we look at this, the coordinate system is going to be formed formed by the intersection of two number lines is what it comes down to. You have a coordinate system where you can say the point 1, 5, and somebody would know where it is because we have two number lines. We call those two number lines the axes of the coordinate grid. So you have your x-axis, if we look at that. The x-axis is going to be horizontal, which means it goes left and right. So over here on this picture, it's this one that I'm highlighting. That's your x-axis. This is showing you a positive infinity to a negative infinity here. Oh man, what did I do? Sorry about that. Okay. So, again, as I was saying, the x-axis is horizontal, left to right. Okay, if you also want to put that left and right is the x. And then we have our y-axis, which is vertical. So it's up and down like this. And over here in the picture, here is your y-axis. Again, up here you're looking at a positive infinity. Down here you're looking at a negative infinity. In the coordinate system, we have what we call an ordered pair. So this is something that students get mixed up a lot on, but an ordered pair is going to be in the form x, y. So you always go left and right first, and then the up and down. So again, if it's like, say I wanted to graph the point 2, -3. 2 is my right because it's positive. So the first number goes right and left. 2 means we're going to go right 2. And then this -3 is the up and down. Since it's negative, we're going down 3. So I go right 2 from the origin, which this point right here we call the origin, and that's at point 0, 0. If we go 2 over from the origin to the right, and we go down 1, 2, 3, this is where that ordered pair would be graphed. So again, all I've done is I've taken a graph point and I put it right here. I went right 2, 3 down from that origin point. A lot of you probably remember that, but it's good to just go through a refresher. Okay, a set of ordered pairs is something that we call a relation, which is the heart of this lesson. A relation can be represented in several different ways. Some ways that we represent it, if you look, it says as an equation, in a graph, with a table, or with a mapping diagram. So probably you're used to knowing what an equation is, what a graph is, what a table is, but you may not know what a mapping diagram is. So the mapping diagram, it says what is a mapping diagram? This is a diagram that shows the relationship between sets of numbers. Okay, so what it actually does is when you see a mapping diagram over there, it matches domain, which are x values, to range, values. And so it's going to take that mapping diagram and it gives you the left-hand side that says the domain. Those are your x values. And then it has the range on the right-hand side. That's your y values. And so what it does is it matches these up. So we have an ordered pair that's represented here of -2, 4. So down here where it says what ordered pairs are represented, we have one that's -2, 4. Okay, we have one, if we look at -1 right here, -1 is also being matched with 4 because that's where its arrow goes. So we're going to say -1, 4. If we keep that up, go to the next one, 0 goes to 6, so 0, 6, and then 1 goes to 6, so we have 1, 6, and then 2 goes to 8, so we have the ordered pair 2, 8. Okay. So the mapping diagram, it's really not any different from a table, except in a table we might say the same value over and over again. Like, for instance, let me just show you what a table might look like over here. You don't have to write this if you don't want to, but if I wrote this as a table, -2, -1, 0, 1, and 2, we would actually want to put the 4 with the 2, or sorry, the 4 with the -2, the 4 with the -1, the 6 with the 0, the 6 with the 1, and the 2 with the 8. You would want to put the number there multiple times. Whereas when you see this mapping diagram, even though 4 and 6 were both used with two different numbers, we didn't have to actually put those in the mapping diagram twice. That's really one of the main differences you'll see between them, but either one works. So whatever you're comfortable with or what the problem asked for. Okay. If you look at the next part, it says key concept, multiple representations. So all this is doing is it's showing you kind of the 4 different ways that we look at relations. The first is just giving you a list of ordered pairs. So that 1, 2, -2, 4, 0, -3, those are our 3 ordered pairs we're starting out with. If we were to convert those ordered pairs into a table representation, we would get this right here, where our x values, -1, 2, -2, 4, and 0, -3. Those 3 elements are showing up again, just in a different format. You go over to the graph, 1, 2, we see that right here. Okay. So we see it again, 1, 2 is right here. -2, 4 is this point right here, and 0, -3 is down here, okay? And then we look at the mapping diagram. Here's your 1, it shows it goes to 2. Here's the -2, 4, and then here's the 0, -3. One thing that I am realizing I forgot to mention up here is that if you put the same range value in the mapping diagram, so say in your range you would have put 4 twice and 6 twice up here, that would have been okay, but the mapping diagram just leaves some freedom where you don't have to put doubles. So just keep that in mind there. Okay, so the last one on this page then, it says example 1, representing a relation. It says express the set of ordered pairs 2, 5, -2, 3, 5, -2, -1, -2 as a table, a graph, and a mapping. Then determine the domain and range of the relation. So if we just start with the table, pretty simple, we label it X and Y. Okay, we look up there, these are all of our X values. Okay, so those are what is going to go in this table right here. Okay, I don't know why it keeps doing that, sorry. Okay, if I go and look over at the Y, okay, so here, these are your Y values. They're going to show up in this table across from their X value. So I just say 2, 5, -2, 3, 5, -2, and -1, -2. my mapping diagram, if I'm looking at that, we're calling this our domain. And domain is just our x values, basically. The x values where our function is defined. So there's our domain. Here's our range. If we look at those numbers that were highlighted in that blue, we have a 2, -2, 5, and -1. When I look at that, I do not see that any of them repeat, so I'm going to put them all in my domain. One thing, it is just what I prefer, and what a lot of times you will see, they go from the smallest number to the largest number. They don't have to. That's just what I prefer and what you will see a lot of the times. So I'm going to do that. I'm going to say -2 first because that's my smallest x, -1, 2, and 5. Okay, so I just went from the smallest x value to the largest x value. Now I look at my range values, and I notice that this -2 shows up twice. It's my smallest number. It shows up twice. I'm only going to write it once right there. Then I'm going to put the 3 and the 5. So now we have everything in here. Now I just have to draw my arrows. So I look at my ordered pairs again. The -2 goes to 3. So I'm going to draw an arrow. The -1 goes to -2. So I draw that arrow. The 2 goes to 5. And the -1 goes to the 5 goes to -2. Okay, so there you have your mapping diagram. Again, if you would have put -2 in your range twice, it's not necessarily wrong. It's just something that's not as common with mapping diagrams. Okay. The last one here, we just have our graph. So now we're going to take these same ordered pairs that we started with. If it helps, you can look at the table. It's a little bit easier to see what those ordered pairs are. So the first one is 2, 5. So remember, the first number goes left and right. Since it's positive, we're going right 2. And then the 5 is up and down. Since it's positive, we're going up. So if I go right 2, 1, 2, 3, 4, up 5, there's my first point. That's the point 2, 5. Okay, go to the next one. It's -2, 3. So we just graphed that one. Now we're looking at this one. -2, 1, 2, 3. We go left 2, up 3. That's where we're getting -2, 3. The next point I'm going to graph is 5, -2. So I go right 5, down 2. And again, I'm just writing these in so it gives you another reference when you're looking back to remember how to graph if you get confused about the x and y. And the last point right there is -1, -2. So we go left 1, down 2. Okay? So, if you turn the page, sorry, go back. At the bottom, okay, there's also this little tidbit of information. It says just determine the domain and range of the relation. So my domain is just going to be a list of x values. So I write this squiggly bracket, and then I put all the x values that were in there. So it's helpful to look at that mapping diagram because that already has the domain set up for you. So I write those 4 elements that were in my mapping. Then I go and I find my range. My range is going to be a list of y values. And if you don't have enough room to really write that in there, there is sort of a space for it on the next page. So don't get too worried. The range, again, look at this box right here. It's a -2, 3, and a 5. So we just put it in the squiggly brackets to show that it's a set of numbers. Okay, so now you can turn the page. We are almost done, okay? We just have a couple more vocab things to go through. So what is the domain and range of the relation? That was what was supposed to be on the last page. So you don't have to write anything there because we already talked about it. Domain is our x values, range is our y values. However, if you didn't write what they were, you might want to just say domain, x values, and the range as your y values, just so that, again, you have it written down somewhere. Okay. Okay, so let's finish this off. It says, in a relation, the value of the variable that determines the output, so it determines the output, it is going to be called the independent variable, is what we call it. And so the independent variable, what it does is it represents or is represented by the x-axis / x values. So a lot of times if you're given a graph or some sort of relation and it wants you to graph it, if it is involving an independent and dependent variable, the independent variable is going to be represented on the x-axis. The variable with a value that is dependent on the value of the independent variable is called the dependent variable. So typically, the independent variable is something that is changing and sort of can be controlled. And then what happens with that independent variable, that would be how you get your dependent. So the dependent variable, the variable with a value that is dependent on the value of the independent. So whatever the independent variable changes, it affects the dependent variable. What the dependent variable is going to be, it is represented, or it represents, the y-axis or y values. Okay, so like on a graph, the dependent variable would be represented on the x-axis. Okay, here are just a couple examples to go through to let you know like what an independent and dependent variable is. So there are 3 different relations here. It says the dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. So our independent that we'd be talking about here, okay, it is going to be the thing that is, I don't know how to explain it, the thing that changes that affects something else. So when I look at this, the more tickets that they sell, the greater the amount of money they can spend. So the independent is the number of tickets sold, because that in turn is going to affect what they are able to spend on decorations. So our dependent variable would be the amount of money. So in other words, this dependent variable, the amount of money, depends on how many tickets are sold. Okay? Okay, we don't really just grab a bunch of money and say, okay, the tickets sold depend on how much money we collected. It's not quite how it works. It's more so you sell the tickets, that ends up controlling how much money you have. Okay? If we look at the next one, it says generally the average price of going to the movies has steadily increased over time. 95% of the time, I would say that if you are dealing with something that is occurring over time, your independent variable is going to represent that time. So as time passes, it changes the increase in price. So the independent is the time that's passing. The dependent would be the price of the movies, of going to the movies. Okay. Again, that price changes based on that time passing. So as time goes on, the price changes and it gets increased, or it's increasing. The last one, it says, as the amount of rain decreases, so does the water level of the river. So again, the independent, okay, that's going to be your amount of rain. And what happens, it says that the amount of rain decreases, so the water level decreases as well. Or it changes, I guess. It doesn't specifically say decrease. So your dependent variable is going to be the water level. So again, as the amount of rain changes, as it rains less, your water level is going to change as well. It's going to either go down if it's not raining, it's going to increase if it is raining. Okay. Okay, these ones down here, they're kind of cool. It says relations can be graphed without a scale on either axis. These graphs are interpreted by analyzing their shape. So I wish I could have been here because we could have discussed these a little more. If you want to kind of look through these graphs, and you can kind of think on your own what you think is going on in these graphs. After I go through what I wrote, feel free to do that because it is open to interpretation. So with this first one, I looked at it and it shows that somebody's riding a bike over time and they're changing their distance. So when I looked at it, I saw three parts. I saw this first part that I'm going to make purple, and then I had my next part, which I'm going to say is orange, and then I had my last part, which says this blue. And so it's really broken down into three parts. I looked at this and I thought, okay, that purple part, a person is gaining distance on their bike. Okay, now we're to the orange part. The orange part, it all of a sudden levels off for a while. The distance isn't changing, but time is passing. So what I interpreted that as is that they stopped for a short break. Then we have that blue part, and I'm going to say before continuing on. So a person is gaining distance on their bike. That's that purple section. It levels off. This is where they're stopping for a short break, and then it starts increasing again. They're going to continue on. Okay. So again, that's kind of how I interpreted it. There's not one right or wrong scenario here. You kind of just decide what you are thinking. The second one, it's not quite as clear. Really, I broke this down into two parts. Part one is kind of this really steep part, and then part two is this other part up here. So part one, I would say a person starts out speeding towards school. Okay, so we see that because it's a steep line there. That means that they went a pretty far distance in a short amount of time. So that's why I'm thinking, okay, they started going really fast on this journey to school. Okay, so they increase their speed, they're speeding. Then all of a sudden it sort of levels off. From this point all the way up here, they really haven't traveled all that far. They've only increased their height a little bit. So on the y-axis, they've only gone up a little bit, but it took a lot longer. So for that second part, I then said that they hit the school zone and had to drive slower the remainder of the time. Okay, our third one here. This one, again, is sort of just kind of weird. It says change in income over time. And you can see that it's pretty, I guess, steady. It hangs pretty steady in the same area. It kind of depends on if you want to interpret it as, is it like a total income that this person has earned in their lifetime? Or is it something like, this is the change in income as far as like each year I had a raise or something? Or is it change in income as like over the course of a month? You know, it kind of just depends how you want to interpret it. All I did is I looked at it as just a short period of time. So I said over time, a person's income has increased slowly. It varies because of commissions. So it's just saying that over time at this job, their income has been increasing throughout that year. But maybe here where you see it's a little taller, I was thinking, well, maybe they're in a job where they do commission work. So maybe those years they just sold more of their product than other years. Okay, so again, there's not one right or wrong answer. That's just kind of one interpretation of those graphs. Okay, so that's all we're going to go through for notes. Thank you for hanging tight here. I didn't really intend to make a 27-minute video. Please go on to your Alex and there will be a new assignment for you to do. Okay, have a good weekend. Have a good rest of your day. Bye.